And thank you for everyone who are attending our session, Accelerating Innovation in the Construction Industry. And as I said earlier, it's going to be chaired myself online and Brian in the room. And we have in this session 6 great papers and presentations. And I will pass on to Brian and to kick start with the first presentation. Thank you.
Thank you very much, Taha, who I believe is in Dubai, correct?
I moved a little bit far away. I'm in Reading in UK.
Oh, okay. We do have 6 presenters, as Taha suggested, so we suggest 15 minutes apiece, ideally 10 minutes plus 5 questions. Since I'm in the room, I'll be the first to give you a signal that you're running out of time, and if that doesn't work, Taha will assist. So with that, what I would ask is that each speaker introduce yourself, simply because in my experience with so many international names, it's more likely that you'll get it right than I'll get it right. So our first speaker. I'll wave at 10. Ready?
The mic on as well. Morning, everybody. My name is Kolosa Madigizela. I am a PhD candidate with the University of Cape Town, UCT, in South Africa. I just completed my PhD this year, submitted on the 11th of February for examination, and I'll be presenting an overview of my thesis this morning with you. That song that you just heard was actually the song that was the official song that was played repeatedly all over in South Africa during the 2010 World Cup. And I played that song just to share a bit of a background to my research as well. In South Africa, preceding the 2010 World Cup, from around, let's say, the time that it was announced that South Africa would host it, that's the time that South Africa saw the biggest boom in the construction industry in South Africa. There was hotels being put up, there were stadiums being put up. It was actually the best time ever that South Africa had performed so well in the construction industry. We saw more jobs, we saw more funding for projects, we saw construction projects that were being built and actually being completed on time. We saw for the first time ever the most successful PPP, which is a public partnership in South Africa, in the building of the Gautrain, which now transports people from parts of South Africa, in particular in Gauteng, to the airport, Pretoria and Sandton. And fast forward to 2020 or even 2018, the picture doesn't look like that in South Africa anymore. And we saw and we heard during the keynote addresses that were spoken about yesterday here about the challenges that the South African industry faces and the industry at large. If you look at the rest of the world, we heard about challenges of an industry that's not diverse. We know about the challenges that we are all going to face now as an industry post the pandemic. Going back to work, what does work look like? The hybrid model, will it work for an industry like ours, which is labor intensive, where we need people on site? So I'm just sharing that just to give you a bit of a background and an intro into my PhD study. So I'm going to talk about a background, which I've spoken about. I'll take you to the research problem, the research aim, the research objectives, and then I'll share a little bit about the methodology that I've gone through. I'll take you through some of the sample and data analysis. I'll share some key findings with you, and then recommendations for future research and a conclusion. So if we look at the background of the study, which I've painted already with the song and giving you a brief background into where South Africa came to. So post 2010 in South Africa, most of the largest construction companies are no longer in existence. And I think our keynote speaker yesterday spoke about this as well, that even in Australia, some of the largest construction companies are no longer in existence. And I can speak from a South African perspective. The downfall for the construction industry in South Africa came from a leadership gap. Some of the challenges that we're facing in the industry at the moment are as a result of leadership. And you might know, might not know, in South Africa, there was a few of the construction companies that were found guilty of cost colluding, which resulted in a downfall of many construction large companies that existed. So that gives a background to some of the leadership challenges that South Africa had. It's traditionally a male-dominated industry. I don't think I have to repeat that. It was said yesterday quite often by the speakers. There's a slow rate of transformation and a lack of diversity, the rapid economic and market changes. Everybody spoke about that. The keynote speakers spoke about that yesterday. And a few of the presentations, if you attended the digitalization ones, and they all spoke about what happens with market changes. We had a beautiful presentation from some of our presenters who are going to present today, who presented yesterday on BIM and some of the challenges that the industry would face because of those changes, and that speaks to the market changes. There's leadership challenges, I've spoken about those, and also the rate of responsiveness and innovation challenges. If I speak from a South African and African perspective, the industry hasn't always been very responsive, and we have not shown ourselves to be innovative. We've taken a lot of innovations from other industries in the IT space, which we've adopted in our own industry, but not groundbreaking ones that we have seen coming from our own industry. The research problem centers around leadership, diversity, and innovation, as I've said. My topic is an investigation into the relationship between leadership, diversity, and innovation. So not looking at those elements in isolation, but looking at them in relation. So I've spoken about the lack of commitment in diversity and innovation. It's one of the problems that identified inadequate and eroded road and water infrastructures. That speaks to some of the challenges that we are faced with, which results in the South African construction industry not being able to reposition itself and being able to respond to these economic and market changes. There's also little information known about the role of leadership in driving and influencing this relationship to advance organizational performance. So at the crux of my research, the main point that I looked at was the leadership's ability to actually drive this relationship between these three elements in order to advance organizational performance, or the inability to do it, which will then result in destruction of organizations and, in essence, the destruction of the industry. The research aim was to investigate and analyze the role of leadership in managing the relationship between diversity and innovation in the South African construction industry. It was to add to the South African construction industry's body of knowledge on leadership, diversity management, and innovation. The research objectives was to investigate and in particular understand what are the perceptions that are held by both the workforce as well as the leadership within South Africa on the importance of these elements. Do they view diversity as important? Do they view leadership as important? Do they view innovation as important in the current contextual landscape that we live in our society and globally, and in particular in South Africa? Analyze these perceived views, obviously, to find out how they can then be resolved. And then also wanted to investigate the extent to which the workforce themselves view the importance of diversity and their leadership's role in driving these issues. And then obviously the most important one that I wanted to do out of this was to then develop a framework that would then assist in mediating this relationship in order to advance organizational performance, targeted obviously at making sure that leaders within the South African construction industry are well equipped to manage this relationship effectively in order to drive innovation. I think research has shown that diversity is important and diversity is required. We need more women in the construction industry, but how do we manage this diversity? Because diversity does bring challenges, different views, different cultures, different perspectives. So the importance of actually managing that diversity in order to see the positive that it's supposed to be bringing requires a lot of effort. The research question, the main research question for my thesis was, how does leadership drive, influence, and manage the relationship between diversity and innovation to advance organizational performance in the South African construction industry? How I defined the South African construction industry for the purposes of this research was it included engineering organizations, consulting engineering organizations that provide services to the South African construction industry, because it is your consulting engineering companies that will design most of these at pre-phase before they actually get to execution and construction phase. So the engineering consulting companies were included in this study, and they were included as part of my sample. I also included facilities management companies that service the construction industry, because at the end of the day, from an operating perspective, they are also participants from a real estate perspective in the construction industry in South Africa. The research methodology, the study adopted a convergent parallel mixed methodology. I went for the mixed methodology because it was important for me to be able to capture the views of the workforce. And because it is an industry-wide, it was important that I'm able to reach as many people and as many participants and professionals within the construction industry. Hence, I went for the convergent parallel and in particular the mixed methodology, so I could do both qualitative and quantitative. The questionnaires were sent out to over 140 participants. I eventually used 114 of those that were viable for the analysis. And for the qualitative part, I interviewed 24 leaders in South Africa across the various aspects within the construction industry, as I said, including consulting engineers, including CEOs of facilities management companies and architectural firms. It was a mix of gender, but very much skewed towards the male aspect of it. But a sample was able to cover as many. I even interviewed leaders of industry bodies in South Africa, because they're also a part of the industry. I've spoken a bit about the sample. In order to analyze, I used a thematic approach, which I taken from Brown and Clark, which step one, which was about transcribing and making sure that the data that I got was then put through, and then step two was about generation of the initial codes. I used open coding so that I could allow the data to actually take me through the self. And most importantly, I used this because it's been proven and shown that it is best for research where there hasn't been a lot of research in that specific area done, so that you can then allow the data to tell the story. The key findings, this is a diagram that shows the linkages between the quantitative and qualitative findings. And what I found was that what the workforce, or the majority, which is not just leaders only, as part of the quantitative survey that was collaborated, what I then found out from interviews coming out of the qualitative interviews that I did with the leaders. And most of the prominent themes that came through was that the South African industry is still male and white dominated, that we are attracting women and previously disadvantaged and people living with disabilities and the rest within the industry, but we are not retaining them. The challenge is a retention issue. We have a culture issue in the industry that we need to look at. Leadership themselves, one of the themes that came out very strongly from the leadership interviews on the qualitative part was that leaders themselves often felt that they are not well equipped to engage with issues of diversity, leadership, and innovation, seeing them as more the softer side and more trained to be technical people, and then how do they then manage diversity effectively. The recommendations and future research recommendations I made were for a wide variety, starting from statutory bodies to the workforce, to leaders, and to universities. So I just, for the purposes of this presentation in the paper, just highlighted a few. Recommendation for industry bodies was to become more actively involved in ensuring that in South Africa, when we talk about these elements, it's not just a tick box exercise, because in South Africa, we have a history of apartheid, which was legalized. And in order to counter that, we've got what we call triple BE, which is broad-based Black economic empowerment, which is a piece of legislation that was brought in to ensure that the industry and other industries within South Africa are transforming. So it's important that we need to make sure that it's not just a tick box exercise, and that it's a continuum thing that will ensure that when we attract women and previously disadvantaged individuals, we create an environment for them to thrive. And furthermore, some of the recommendations came for leaders to ensure that within their own environment, they've got key KPIs and scorecards that ensure that the measurement of these elements is done very well. One of the things that came out quite strongly was that it's important that we define what does innovation mean for the construction industry. Future research, innovation came out quite strongly as the element that is most challenging and most difficult to engage with in terms of the construction industry. In particular, if you compare to like a chemical engineering, it's easy to say innovation, I created a new chemical. Within the construction industry, how do you define it? So for the purposes of my study, innovation was defined as the ability for leadership to create, develop inclusive solutions to problems that are countered due to market changes and due to challenges that the industry faces. And that is how innovation was defined in the study. In conclusion, the framework, the mediation framework, which was a main objective of this research, which defines how leaders can mediate for this relationship, which shows the different relationships within it, which is execution, the industry bodies, the clients, and society at large. And that describes how then these would interact together. And the key is that there should be mediation at each and every intersection and point. I know I don't have time to go into detail, but if you want me to unpack it a little bit more for you, I'm here for the rest of the day, and for the rest of the conference, I can take you through it some more. In conclusion, the study evaluated the relationship between diversity, leadership, and innovation in the South African construction industry. It provided answers to how leadership drives, influences, and manages the relationship between diversity and innovation to advance organizational performance. Ultimately, the study contributed to the industry's body of knowledge, but most importantly, to South Africa's transformation agenda, which is so important. Any questions and comments are welcome.
We have time for maybe a very quick question.
Thank you for your presentation, and especially for the music. I think it made me happy this morning. My query is, you did speak, quite well about leadership and diversity. When you speak of diversity, I think you are looking at it particularly from the perspective of inclusivity of women in the construction in South Africa. To what extent is the government involved in this area? To what extent are they trying to, improve the system? Because without government participation, it may be very difficult to get it moving.
It's actually a very important question that you're asking, and that is why in my sample, I did include industry bodies like the Council for the Built Environment, SAICI, all of those governing bodies that have a relationship with government. And I spoke about what we call triple BE, which is broad-based Black economic empowerment, which is a government instituted piece of legislation. So government is very involved from a policy and a statutory compliance, but they don't push it very much in the private sector. And in South Africa, we've got what we call the Department of Public Works, which would be quite similar to the gentleman who presented yesterday as a keynote and spoke about the development running Build It for Australia. We've got what we call in South Africa GDID, which is the Gauteng Development Board, which develops work on behalf of government. So through that, they've tried to ensure that transformation happens. But unfortunately, the bigger players in South Africa are private sector.
Thank you very much. That was really excellent. Thank you.
Thank you. Thanks.
I think Mr. Lars online.
Yes, Grammy.
Hello, can you hear me?
Yes.
Super. I just have two observations really very quickly. The first one was about your definition of innovation, which I thought was kind of interesting, because it was all about the creation of something, but you said less about the uptake then of the innovation. So creating something is the first step, but then the uptake is kind of the second step. Well, in actual fact, they're kind of interrelated, aren't they? So that was just an observation. It's not a question for you. And the other observation was around, you talked about obviously diversity, leadership and innovation, this relationship between them and how leadership influences them. It's just an observation about how robustly you can defend the leadership being the kind of an isolated key variable over all the other things that could influence diversity and innovation. It's just an observation, not a question for you. But great presentation. Thanks ever so much.
Thanks, Graham. Thanks for those.
You're welcome.
Can I just make a comment quickly on the first one? Sorry, I think I didn't unpack it properly. I define innovation for the purposes of this research, and I've looked at the whole creation and the innovation theory and unpacked it in detail. But for the purposes of this particular study, I defined it as more towards problem solving. So identifying inclusive solutions to the problems that come from the construction industry and from society through infrastructure.
Super. Thanks.
Thanks you
Thanks,
again.
Graham.
Thank you.
Yeah,
Next speaker.
Thank you very much. I just have a comment. I think we are a little bit lagging behind time, and if I urge all presenters to keep on time, and we will be a little bit maybe more strict for the next coming presentations. So please keep on time. Thank you.
Thank you, Taha.
Thank you. Hello, everyone. Yeah, I'll be speaking this morning on combined effect of fiber reinforced fiber geometry and aggregate size on the workability and mechanical properties of steel fiber reinforced concrete. And these are the authors. Myself, Olubisi, will be presenting. I've got others, Iman, Nassif, Obas Ebon, Roy Jean, and Job Momo. That's me, and I'm from London Saba University, and I belong to this Center for Integrated Delivery of Built Environment, IDOBE, and that's my email. I'm a senior lecturer in construction project management, and I'm finding on Twitter and LinkedIn. The outline of my presentation this morning is on this introduction, brief introduction, the objectives of the study, significance of this study, the experimental work, and the results and conclusion. So the concrete, as we all know, is a very important material all over the world, can be found anywhere in the world. And the strength is incomparable with any artificial material. Though it has its own problem, but research is ongoing how to reduce the CO2 issues, global warming, but the concrete is inevitable in our structures, in our built environment. As good as concrete is, the concrete is brittle. And because of this, the failure nature is undesirable. And that's how we want a kind of innovation about this concrete to move from brittleness to ductility. Because there is the conventional reinforcement bar are stationary within the region of a concrete. And when crack is initiated, ideally there should be transfer of load from the concrete to the reinforcement bar to support. But before this load is fully transferred, initiation of crack has occurred. And we need something that will provide multi-dimensional resistance to the crack. And that's what these steel fibers do within the concrete, so that they could stop, resist, bridge the initiation and propagation of cracks from micro to macro. Micro is very tiny, we can't see with naked eyes, but when it becomes macro, we could see that, and that's what causes failure. So the introduction of short discrete fibers into the matrix substantially improves many of engineering properties of concrete, especially the ductility and durability. So, and this is just to arrest the cracks. When the cracks is initiated and it is bridged by these fibers, it stops. Even at initial cracks, there could still be post-cracking capacity of the structure. So the objective of the study is to look at the effect of fiber geometry. We're talking about the length, the diameter, the aspect ratio of fibers. The aspect ratio is the ratio of length to diameter of fibers, the dosage, and the maximum aggregate size in the concrete. Look at the collaboration and how to get the best performance of this material. Then we will now look at the influence of these variables on the workability and effect on the flexural properties of concrete, the steel fiber reinforced concrete. Why is this study very important? Now, because the design codes for steel fiber reinforced concrete is not fully developed. It's new innovation, but we need more understanding about the internal mechanism of this material before we could develop the design code. And to do this, there are several cases of fiber reinforced concrete today, like slabs, that needed to be removed for quality issues because of lack of understanding of how the mixtures, the materials are selected. So understanding the preference of materials for an efficient result of steel fiber reinforced concrete is very crucial. So these are the experimental work, the variables, maximum aggregate size using 10 mm and 20 mm. The fiber length, two of the fiber length, which is 50 mm and 60 mm. The aspect ratio, that is the ratio of the length to diameter, three of them, 45, 65, and 80. Then we have the fiber dosage in the concrete, the concrete without the fiber at all, the 25, 40, 50, 60 kilogram per meter cube. Then we have, these are the fibers, the length, the hooked end fibers. We have different, we have the natural fibers, we have the agricultural fibers, we have the polyene styrene, and so on. But these are the steel fibers for this particular research. And we have the mixtures, the cubes, and the beams. So these are the results from the workability result. You can see that of 50, 60, 60. These are the length, and these are the aspect ratio. And these are the dosages and the slump test used for the workability. Generally, we could see from here that the 20 mm show better workability than the 10 mm aggregate. And this might not be unrelated to the non-compatibility of the length of the fibers and the size of the aggregate. And with this, that can result in balling effect, where we have coagulation of steel fibers together, coming together, and it will affect the homogeneity of the concrete. And this is the compressive strength result. Well, steel fibers in concrete will slightly affect the compressive strength because it is mainly for the flexural properties. And even with the compressive strength, we could see that the optimum result is from the 50 kilogram per meter cube for both aggregate sizes. When there was an increase until this level when it began to decline, because the more the fibers into the concrete, the lesser the flow, as we saw that in the workability, and that has a subsequent effect on the compressive strength. And this is the flexural behavior of normal concrete and steel fiber reinforced concrete. You can see from there that we have the plain concrete, and you can see the brittle effect. After the initial crack, that's the end, everything came down. Where we have all those materials with steel fibers continued, even after the cracking, we have the post-cracking capacity, the strain hardening of the concrete, even with we're able to carry more load than the load that caused the initial crack. And we could see the results from this side, the length, the 80, 60, having the highest post-cracking capacity before they could come to the end where they failed. They could still carry more load at that end. So in conclusions, steel fibers in concrete generally improve the mechanical properties of the materials, generally. The workability of fresh concrete declined as the fiber dosage increased because, and even in the compressive strength, because of the more the fiber in the concrete, the more difficulties in the compaction of that material. So that led to the sometimes reduction in the compressive strength. The flammability of steel fiber reinforced concrete has a direct influence on the structural efficacy of the hardened concrete. And increase in maximum stress was up to 80% with high dosage of longer, thinner fibers. High post-cracking strength, particularly at 50 kilogram per meter cube dosage. So adequate fiber dosage, that is the right material, the right dosage. Yeah, thank you. And the right combination of fiber geometry and the aggregate size were also observed to give better results. Thank you. And any questions? And I will still be around, and these are my details.
We do have a couple of minutes for questions.
May I come in?
Yeah, please.
Yeah, thank you very much for the presentation and also the results and what I see the results, they have mixed outcomes, if you like. To some extent, there are negative impact on the compressive strengths and workability. and with the mixture of fiber, the sizes, the dimensions, and the magnitude, that may be reversed. So, in your judgment, given this research and the continuity of the research and maybe more results to come, what kind of adoption do you expect if you get results which can compete with the normal reinforced concrete type of approach?
Well, thank you very much for that question. And let me say, the research is ongoing, like I said, and what we are doing at this moment is to gather more understanding, especially the internal working. This research is part of the main research of looking at the distribution and orientation of steel fibers within the steel fiber reinforced concrete. Now, the orientation matters, the distribution matters. And after this, there is an X-ray CT scan of adding concrete that will combine the result and the result from this XACT with that of laboratory testing to see how these are related. With this, you will be able to have confidence in either partial replacement of steel of the conventional reinforcement bar and or complete replacement of the conventional reinforcement bar for the strength required for the materials to stand. So ideally, the steel fiber reinforced concrete will not affect the compressive strength more. It's slightly affected because it is mainly for the post-cracking tendency. That's what the steel fiber do in the concrete. It's not really for the compressive strength, but at the same time, the strength is not really affected when we carry out our compressive strength.
Thank you very much for your presentation. I agree with you. I think for the fiber, your objective is just not for the compress. So you want to look at the crack. So I agree with the Prof. The compress test is not an accurate test. You just did that one because you are not working on the compress test. And you compare it to the plain concrete, I think is also not accurate because you are just moving to reinforced concrete. Now you are comparing it with the plain concrete. So maybe in the future study, you just try to adjust those things. And also for the future study, I just suggested to look at the other studies just done like a nano fiber. Recycle nanofiber, we just try to do that one, or the carbon fiber or the ceramic fiber, we just do that one. So it's just increase the capability and also workability of the concrete. A lot of focus is about the reducing the carbon emission, and you know that steel is the highest one. So I strongly suggested to look at the other fiber in your future study. But thank you for your presentation.
Yeah, thank you very much. There is a work going on with even the steel fiber compared to the conventional reinforced bars on carbon reduction, because the reduction in the conventional reinforcement bar will bring about a lot of reduction in the carbon footprint. Thank you.
Thank you. We're out of time. Nicely done. Thank you.
Okay, now it works. Perfect. Okay. Hello, everyone, and thank you for attending this session. My name is Philipp Schönfelder. I'm with the University of Bochum in Germany, and today I'm presenting the topic of deep learning-based text detection on architectural drawings. So, let me start off with showing you two examples of technical drawings. So on the left-hand side, you can see an example of a floor plan image which the resolution is actually quite messed up on this slide, but I just want to draw your attention to the vast number and variety and style of all the text elements in the drawing. So for example, the text elements are scattered all around the drawing. They are different in terms of size, also position, of course, orientation, and also the style of the font size, for example. On the right-hand side, there's another example of a technical drawing. This is a section view of a bridge construction drawing. Of course, they also cover some text elements. And I'm showing you this. This actually is the motivation for the study, because these text elements carry a lot of semantic meaning that is important to consider when you, for example, reconstruct a digital model from these actually analog files, right? So the largest scope of our research project is to recreate digital twins from analog drawings. And to do that, not only do you have to reconstruct the geometry from those files, but also some semantic information, and that mainly lies in the textual annotations. And therefore, it is necessary to automatically detect these annotations and analyze them in a way. However, the existing OCR software that is currently on the market is pretty much optimized and tailored towards standardized style text documents in a standard format with fluent text lines. And it doesn't work so well, actually not at all for the technical drawings, because of this characteristic display style of the text in the drawings. And therefore, our goal is to develop a specialized text detection tool based on deep learning that can cover this. There's two disclaimers, actually. The first one is that we only deal with pixel-based drawings. That is not so much a limitation, but rather I just like to let you know, because, for example, if you have a vectorized drawing in the form of a CAD file or a PDF file with vector information, you could always render this into a raster-based image, and then our method would still be applicable. And the other thing is that we only deal with text detection, so that means just localization and not a recognition of the text. So here's the more specific definition of the object detection task that we're dealing with. So you can see three distinct classes of text that we try to detect. The first one is just a basic text box. So all these green highlighted elements here are basic text box, single lines, of horizontally aligned text. Then the second class is vertically aligned text, but still a single line. And the third class is a bit more general. It's logical text boxes. So whenever there are multiple basic lines right next to each other and also aligned vertically in this case, then it's considered a logical text box. So this would, for example, be for room stamps that naturally have multiple lines. And now this is what we try to detect with a deep learning model. And therefore, we need a training data set of drawings that cover text bounding box annotations. And this is where open source data sets come in very handy. There's two that we used for this study. The first one is the CVC-FP dataset that has about 120 ground floor images, and the Kubicasa 5K dataset that has 5,000. And now we didn't label all of these, but around 400 of these we also labeled. And then this is already more than 500 training images. But however, the resolution of these images is quite high, especially in the CVC-FP dataset. Sometimes these images have resolutions up to 700 pixels in side length. And this is too much to process for the deep learning models. And therefore, the images are broken down into smaller tiles of either 256, 512, or 10 or 1026 to 24 pixels. And this, of course, increases the number of training images in the dataset even more, up to the point where, for example, the tile size 256 pixels yields more than 8,000 training images. To further improve the quantity and also the variety in the dataset, we also use data augmentation. Two techniques, actually. The first one is horizontal flipping. It's quite self-explanatory, which you can see in the upper image right here. So each of the drawings is simply flipped with the annotations to double the size of the dataset. And the other technique is the mosaic technique, which is mainly motivated from the YOLO papers. So in this technique, you take 4 sample images out of your training data set. You shrink them so they are the half of the tile size that you want, make them square, and then you concatenate them together to form a new training image. And you can do this as many times as you want. However, in the study, we just used it to double the size of the data set once more. Now, these are some of the results of the cross-validation experiments that we carried out with the training data set. So that means you split up the training data set into test and training 10 times. Each time you train on a different subset of the data set. And these are our results. I'm not sure if they are very legible, but these are a lot of numbers, and I just want to point out a few of them because there's a lot of combinations of different models that you can use for this task at hand, and tile sizes and data sets and augmentation techniques. So the most important thing right here is that the CBCFP dataset is apparently a lot easier to learn for the model than the Kubicasa 5K dataset, and that is supposedly because the quality is actually just much nicer for the CBC dataset, which makes it easier to learn. So there we can achieve average precision score up to 96% actually. For the Kubicasa 5K dataset, it's just over 90%. And the other important thing here is that we use the FastRCNN model, which is the technique that we propose for this task. Actually, it's not our model, but we use it for this purpose. Another model that has previously been used in other papers that deal with text detection and drawings is the EAST model. EAST stands for efficient and accurate scene text detection. So as you can tell by the name, it's not designed to detect text and drawings, but rather in scenery images. But it's something that is used, and it doesn't work as well as the FastRCNN model for our data. So this is why we actually chose the FastRCNN for the purpose. And it's not production ready yet, but there's still some room to improve. But it also already works much better than the EAST model. So here are some examples of the actual detection in action, I would say. So the green boxes in this case are the basic text boxes horizontally aligned. The purple boxes, they're just quite a few, two of them in the middle of the image actually. They are the basic text boxes vertically aligned. Then we have some of the pink boxes that are indicating the logical text boxes. In this case, it's just room stamps. And then some other class, it's not really visible, but it's a residual class, this one, catching all the residual elements that have other orientations than vertical and horizontal. And as you can see, it already works quite well for these example images. Now, so the main contribution of this study is to propose this model as a more general applicable text detection model for architectural drawings. However, there's still some limitations. The first one is that we only applied this to floor plan images so far, and not, for example, for the construction image drawings that I've showed you in the first slide. And also, as I said, this is only localization of text elements, but not so much the recognition. So this is, of course, one important step that is still need to be taken. So future research would cover an enlargement of the data set, both in terms of size and also variety of the data. And also the use of more diverse text detection models. So far, we've only tested FastRCNN, but there's also other models, for example, the YOLO series or the efficient DAT model. And then, of course, the pipeline should be extended by an actual OCR module that after the text is detected is also recognized. And this concludes my talk, and I'm very happy to answer any of your questions. Thank you very much.
Are there any online questions to begin? Questions in the room?
Hello. I might have met this group last year at EC3. Was that one of the best paper award in EC3 from your group? So my first question is, what is text location you meant? Are you just recognizing where the text is, or and how are you going to use this text location future in your research?
Yeah, so what I mean by location is simply 4 coordinates actually, is the X and Y position on the drawing and also the width and the height of the bounding box that surrounds the text element on the drawing. So this is what we define as the position. And of course, this by itself is not of use. So this text still has to be recognized as text and translated into ASCII code. And then you can analyze the semantic meaning of it. For example, it will make sense as you try to analyze the dimensions in the drawing, right? So of course, you can always take a 3D scan to get the as-is data, but the drawing might give you the as-planned data, as clearly shows the dimensionality. Also, the drawing might cover a material that you cannot see visually in the building, so you can extract that kind of semantic information from the drawing.
That's great. And then I have another question then.
Yeah, sure.
Because in engineering drawings, we often have different sections that you have to refer back and forth. And how are you going to link the text, for example, in the floor plan with the one in the section plan?
Yeah, there's also another research topic we're working on right now that basically takes these text elements and then classifies them as, for example, the section reference that has typically just a letter, right? And links it to the other view where the section actually is represented with the section title that that just tells by the title of the view the section reference. For example, if there's a section AA, then there would be another view referring to that section symbol, and there would be the link between the two.
So so eventually, would you imagine the outcome of this project would be something that can automatically translate or remodel the technical drawings into an semantically enriched BIM model? Is that what you're trying to do?
Exactly. This would be the overall goal, which is, of course, this way in the future, but this is one step in that direction, yes.
And how long do you think that you need to achieve that goal?
This is hard to tell. I mean, there's many steps to be taken in that process, but we're already dealing with some of them. For example, the detection of text and also the section views, also some geometry detection as well. Yeah.
Okay, good. Thank you.
Okay, we're going to pause here between speakers. So thank you very much.
Thank you.
Our next speaker, I believe, is online. So we're getting set up for that. Thank you very much. That was excellent.
Speakers online, they can start now.
Okay, I think we're ready for the next speaker.
You have to show you these.
Oh, we seem to have frozen.
Graham, are you ready?
He's ready.
I'm ready. Yep, I'm ready.
We're ready for you. Thank you.
Okay. Do you have my slides up? Because I can't see if they're up or not.
Not yet.
Okay.
We're working on it.
Just to correct.
Yeah, no worries. I'll be here. I'm not going anywhere. Don't worry.
Yeah, this should be it, right?
Is that correct?
Yeah. Exoskeletons, yes. We're ready.
Yay.
Advance the slide. If you could just ask for the next slide, please.
Yeah, will do. Okay. Thanks, Josh or Joe. I'm not sure who's steering there, but thank you very much. Can you hear me okay?
Hear you fine.
Excellent. Okay. So good morning, good evening, good afternoon, depending on wherever and whenever you are in the world. I've got no idea what time it is where I am. My presentation is about the uptake of exoskeletons and how they'll become stabilized, proposing a particular theoretical approach. So we can have the next slide, please. So just a quick bit about myself. I work at the University College of Estate Management in the UK, Associate Dean for Sustainability. I have a remit with the CIB. I'm one of the joint coordinators, and I'm actually also a visiting professor at RMIT, which makes the fact that I'm not there even more depressing, the fact that I'm in England, but never mind. I'm sure I'll get over there. So if we could have the next slide, please, that'd be great. Thanks. Okay, so I kind of popped something up that's a little bit different to start with normally, just to get people thinking. And but my entire academic career, which is going on for 25 years now, has always been about the uptake of innovation and about the adoption of innovation and how innovation happens. Okay. There's thousands and thousands of quotes from the construction sector about how the sector seeks to be more innovative, and how you know that we're always in a time of change. There's always a new dawn around the corner, and we've heard some of the phrases kind of used around this in the conference so far. But these are just a couple of recent kind of quotes just to get us thinking. And the reason I put the Bob Dylan quote there is because the times, they're always changing. Okay, the sector is not static; it is fluid. It is changing all the time. And the minute we don't think like that, we're kind of shooting ourselves in the foot, I think. So if we could have the next slide, please. Okay, so as I said, most of my academic career has been around studying the uptake of innovation. Now, this piece today is really a think piece. There's no empirical data, there's no findings. Okay, what I do have though is some kind of potential propositions based around the literature, and I hope that these are kind of thought-provoking. That's my wish here. So the particular innovation that I've been interested in of recent is these things called exoskeletons. Now, these are mechanical devices which can be worn by operatives on site. They can be either passive or active, and what that means is they are either powered by motors and therefore have a battery, or they are powered using a complex cam system, so therefore it kind of exaggerates the amount of power you can generate. Okay, they are being trialed in the construction sector. They are already used in a number of other sectors, but as yet, and this is the bit where I find it starts to get a little bit more interesting, is we don't yet know how the construction sector is going to define exoskeletons. Okay, and I'll come back. That's the kind of premise of what I'm kind of talking about here, because the sector's defining them and they're defining the sector. All right. So if we could have the next slide, I'll show you some pictures. Excuse me, I do have a cough. These are just some images I've stolen from the internet, obviously, as you do. The top left corner, as you're looking at it, is a passive system, so there's no power. There's no motorized parts to that. It uses cams to exaggerate the strength of the person's arms. But then the systems can get more complicated. So like in the bottom right, the person drilling, they've got an entire piece of equipment to help support that really heavy drill. In the bottom, in the middle, where the rebar is being done, that piece of equipment is obviously supporting the person's arms. Okay. And then the top right, what have we got? We've got a completely autonomous exoskeleton for moving things around on site. Okay, so there's kind of three versions there really. The autonomous ones aren't being trialed in the construction sector at the moment, not that I'm aware of, but the others are. So that's kind of interesting. But that gives you hopefully a picture of what they look like and what I'm talking about. So if we could have the next slide, that'd be great. Thanks. Now, the built environment, robotics, and exoskeletons. There's a lot of research done already around robotics, around kind of bricklaying robots, around flying factories, around the robotics from that angle. But there's nothing really done yet around exoskeletons that I'm aware of in the actual sector. There's kind of anecdotal stories. There are companies trialing these bits of kit at the moment. Initially, the challenge around the use of exoskeletons has been a technical one. Okay, if you think back to kind of, I don't know, crazy science fiction, where these kind of devices would have been very big and clunky. Today, the technology that we have means that they're no longer big and clunky. They're no longer cost an absolute fortune. They're obtainable. They can cope with the type of environment that construction offers. Okay, so what we have now is we have something that's a little bit more of a socio-technical challenge, as in how will the sector respond to these innovative tools that we could use, the innovative things that we could use to help us. Okay, so that's kind of where my thinking is. And as I started to think about that, I started to think about how exoskeletons will or could potentially impact the sector. Again, that's not the focus yet, but the exoskeletons could impact productivity, could allow people to move more things, lift more things. That in effect would mean that we might have to think about how we plan activities differently, how suddenly the duration of an activity becomes much shorter. So the kind of production methods, that leads to things around risk assessments and method statements. And then I started to think a little bit about how it might benefit the actual operatives with their general well-being, their ability to do the job for longer periods of time without ending up absolutely exhausted at the end of the day, so they don't end up with reoccurring health issues. Okay, so I started to think about all different things, and I just started to realize that there's lots of things we don't yet know. So if we could have the next slide, please. Now that led me, along with some of the literature in some of the other sectors, to think about how we as the construction sector might start to define exoskeletons. And these are in by no means an exhaustive list. These are three versions of reality that I think could happen as the exoskeletons are adopted and uptake occurs. I thought we could either start to conceptualize an exoskeleton as a piece of plant, so like a crane, like an excavator. It's a piece of plant that's operated. Okay. We could also start to think perhaps about an exoskeleton as something that is used, so simply as an operative's tool, a tool that an operative brings to site, puts on and does what they're going to do with it. It's their own tool. And then I started to think, well, another way to think about it is, because one of the terms that is often used, they're called wearable robotics, as well as being called an exoskeleton. So I started to think in terms of the exoskeleton being worn, as in you put it on like you would put PPE on, as in personal protective equipment, to help you, to make you more safe. Okay. Now each of these three is perfectly acceptable, but each of these three versions of how this will unfold in practice is going to have different connotations for the sector. Okay. So if we could have the next slide, that'd be great. In order to do this, in order to think in these terms, I started to obviously look at different theoretical positions. And the one that kind of leapt out to me, of course, was moving away from technological determinism, thinking about the kind of where the agency resides for us to think about how the uptake, etc., will interact. And that led to science and technology studies, led to SCOT, as in the social construction of technology. I'm sure a lot of you are familiar with that sort of literature without me going into detail. Now, there's two key concepts in there. One is about interpretive flexibility, which is around the interests of people and how those interests start to form into social groups, relevant social groups, and therefore they have more power to shape their innovation the way they want. And then around closure, and that is where the innovation starts to reach some form of stability. So where it starts to become defined for a period of time anyway. So that's the lens I've been trying to use, and the kind of things I've been trying to privilege by drawing upon social construction of technology. So the classic, pinch and biker stuff, it's not new at all. So if we could have the next slide, please. So I'll just skip through these three kind of versions of reality as I see them at the moment. And my hope obviously is, I should have probably said this earlier on, my hope obviously is to engage with some of the organizations that are trialing these, and also some of the other stakeholders, and start to get a sense of empirically about what is going on. So if we think about if we conceptualize an exoskeleton as a piece of site plant that's operated, suddenly we've got plant companies seeing this as a new opportunity. They could expand their business. They could have a stronger role. We would start to create new operatives who have to have a particular license to drive this piece of operated plant. They need to be trained. They need to be tested, etc. We start to get into the regulation, into certifying these people. Okay. What impact might that have on wage structures? When I worked in the construction sector many moons ago, the highest paid person on the last project I worked on in the central London was definitely the crane driver. Okay, would we end up with a tiered system of labour rates? Okay, and then there's the impact on the programme, as I mentioned. You might end up with programmes that are bid and projects that are bid where exoskeletons are used, and therefore they can be done quicker. You might end up with them where they're not used and they're perhaps done a little bit slower. So the interests around how, if we conceptualize exoskeletons as an operated piece of site plant, are kind of interesting for us. And the sector at the moment has got no idea how to respond to this. There are no regulations. There are no plant companies thinking about leasing these out or hiring them or training operatives. There aren't any. Okay, this doesn't exist. There isn't a structure yet for this stuff. So if we have the next slide. Thank you. So we start to think what happens if exoskeletons become stabilized around being a tool. This might mean that they become the property of a firm that somebody works for, or it could be an individual's own tool. They might lease it, they might rent it. Again, that means that there could be new business opportunities for particular firms around providing these on a lease or rent mechanism. Would an operative be able to actually justify purchasing or engaging with this? Would a firm be able to? Would they be able to be more productive? Would they secure more work? No idea. I started to think about the safety and security as well. If it's a person's own tool, how responsible are they for that tool, and where could they keep it? A simple thing such as that. And I started to think as well, I think I mentioned this earlier, about the kind of fatigue issue. Anybody that's ever worked in the construction sector and seen the kind of physical nature of certain tasks, having a piece of equipment that can help reduce that fatigue is a really powerful thing for us to have a sustainable workforce and look after the people that are actually doing the work. Next one, please. Thanks. And then finally, my third thought at the moment is what happens if exoskeletons became a piece of standardized personal protective equipment. Imagine that. Everybody that goes onto site has to have one of these exoskeletons on. It would then become heavily regulated. There'd be legal implications if you didn't have your exoskeleton on. It'd be like if you don't have your hard hat or your high-vis jacket. And I think that would be a bizarre situation for us to try and envisage at the moment. But a construction site in 10 or 20 years, every operative might be walking around with some kind of exoskeleton on, and it just becomes the norm. Okay. The other issues here, you kind of get the idea. I started to think about how we might fund these things as PPE, if the contract would have to fund them, how they would be maintained. Differences between different countries. So if you're a firm maybe based in the US and you want to go and work in parts of China, how would the regulations differ, or vice versa? And all of those things are currently unknown. There is no structure for us, no guidelines for us on how to use exoskeletons. We could have the next slide. Thanks. So I won't read through these yet. I'll just make one more point, and then I might just touch on a few of them. I think if we were a practitioner and we were innovative and we wanted to look after our workforce and our operatives, and we wanted to be more productive, and we wanted to somehow invest and start using exoskeletons. The structure of the sector at the moment can't really cope with that. This is why I think, and I've kind of positioned this as a socio-technical problem. We've got issues in the sector that need to be thought through to let the sector catch up with the technology a little bit. And then the technology can start to shape what some of those things look like. Hence the kind of 3 scenarios of, is it operated, is it worn, or is it actually used? How will we end up defining an exoskeleton? Okay. And there's a lot of other kind of other interests here that could play a role. So the training providers, maintenance, the site dynamics. I think there's issues around how productivity would be recast for bidding on work, etc., and so on. Okay, next one, please. All right, so just to summarize, I've drawn this lovely little helix here because as I started to think about this and write the paper, I started to think, well, it may not be just one of the 3 scenarios I've thought about so far and that the literature kind of points towards. It may well be that it's a combination of all 3. It may well be that one of them falls away and it's a combination of 2. I don't know yet. I want to do the empirical work. So I would say that exoskeletons have got a role to play. I would say that they certainly haven't reached any version of stability yet in a SCOT sense, as in a social construction of technology sense, drawing on that literature. I think there'll be a range of interests with people seeing it as an opportunity, and they'll have their own agendas and want to shape the innovation for their own purposes. But the final point really is about the institutional and kind of structural makeup of the sector is not quite ready yet, sadly. Next slide, please. I think that is back to Bob Dylan. So just a little cheerful note to end on as we all try and navigate our way through academia at the moment. The world of research has gone berserk, too much paperwork. So I can highly recommend a bit of Bob Dylan when you're doing a conference paper. Most amusing. Okay, all right, that's me. Hopefully short and sweet, and I've helped you get back on time a little bit there. I haven't seen any time warnings, so that's good. And thank you very much for listening. Questions, please.
Thank you, Graham.
You're very welcome.
If I may throw a question, is that okay?
I'd expect nothing less from you, sir.
Yeah. Okay. I noticed that Vinci as a contractor and operator and facility management as well. They used the exoskeleton in airports where they operate these airports, mainly to support workers to lift luggages and from one place to the other. But I didn't come across Vinci themselves using it on construction sites. So my point is, what are the reasons? Is that because when you do it in a controlled, defined environment, that will be more productive, more efficient? And is there any issues on site of constraints or limitations which will jeopardize the benefits of using them? Just some thoughts about that. Thank you.
It's a great question because I'm aware Vinci were using them. I'm aware that they are used in the automotive sector. I'm aware that they are being used by some companies already, construction companies in the States. Okay. I think in the UK at the moment, there are maybe 5 or 6, without naming them. Vinci's one of them, but without naming them, there are companies trialing them at the moment in the UK. But I think, I started to allude to some of the challenges, I think. So as in, we obviously have quite a complex subcontracting kind of culture in the United Kingdom, and no doubt in other parts of the world as well. So if the operative if Vinci is kind of a management company in a way, isn't it? So you know, the chances, not the chances, but I know from doing research with Vinci, which I have, that they don't have the kind of, you know, they don't employ, let's say, for example, a dry liner, somebody to do the internal partitions of a building. That's three tiers of subcontracting down, if you were. And it's the dry liner who's got to be lifting their arms up every day doing this. They would be the ones to benefit from it. Like you gave the example of the baggage handler, absolutely. But I think that the structure of our sector at the moment, we need to work out, and this is why I think it's a socio-technical issue, the structure of our sector, we need to somehow work out how this innovation, which does seem to have a lot of benefits. I mean, I'm not championing it. I don't mind if it gets adopted or not, but it seems like it has a lot of benefits. What I'm interested in is what actually happens as an academic. I think, yep.
We're just going to have to, we're really running behind time. And
yeah, no problem. I'll chat to Taha off.
But just let me invite you. This is Brian Kleiner, Virginia Tech. We're doing considerable research on exoskeletons in this with a socio-technical framework, and I invite you to make contact, and I'll share that research with you.
Top man, thank you so much.
All right, great. We have another online presentation, innovation in Nigeria. The speaker there.
586. Look at that.
I'm looking. Is the speaker Abel John? Are you there? If not, we'll move on to our present speaker. Okay, so we're going to move on. We don't see the speaker online, and we're going to move on to our, I guess, what will be our last speaker. In the red button off.
Good day, everyone. Wherever we are joining the presentation, good day to all of you. I'm Ruvini Adrisinghe from RMIT. I've been working as a Vice Chancellor's Research Fellow at RMIT, which gave me a unique opportunity to initiate and lead interesting research projects which I'm passionate about. So this project I'm talking about today is ongoing project, which is called Smart Safety Vest. Graham's research actually sort of set the scene for my research topic today. The paper title is Exploring the Thermal Conditions in Construction Sites Through Internet of Things-Based Methodologies. And my co-authors, Mala and Mala brought the thermal comfort expertise into the project, and Ali, they both had to leave, sorry about that. He brought his statistical analysis expertise into the project. All right, so we all know that construction industry is a dangerous industry around the world, globally. So particularly about heat stress, given the fatalities, lost time injuries, and serious compensation claims around the world, regulatory bodies are increasingly recognized the hazards due to the heat stress conditions, and DIOSH, OSHA, WorkSafe Australia, they all are also acknowledging the fact that climate change is going to be making the situation worse. So this concept of smart safety vest system came to give a technological solution for that problem, to measure physiological data of the construction workers and to generate warnings in real time. This shows a very early stage of the prototype, which I presented in 2014 to WO99 Health and Safety Conference. And it's been through several stages since then. So I've been very passionate about this digital innovation in construction, and I've been advocating since 2014. Could I have move it to the next slide, please? Does this work?
Should be working.
Needs to be slow. All right. So as we all know, we are heading to this industrial revolution, Industry 4. And construction is perceived as a lagging industry for decades. It's a known fact. And but now we are hearing more and more these buzzwords like pervasive construction site or smart construction site, Internet of Things, cloud computing, data analytics, AI, and exos, as Graham just mentioned. So they're becoming the normal to us. So I wrote this paper in 2019. It's so my vision about this digital skin in construction, heading to this smart construction site. For example, I mentioned smart construction workers in future will be having Internet of Things sensors attached to their PPEs as part of their regular sort of wearables. And also in this paper, I'll make sure that you are fed on time, so I'll quickly go through this. I talked about technology translational levels. So when we start from basic scientific research, how do we make sure that the systems are fully operational, industrial systems are available in the end? So various milestones were highlighted. You can refer to the paper, but briefly, prototyping and validating in laboratory setup and field trials, and also fully integrated system trials and so on. So moving from this slide, SmartWest also went through a number of iterative levels, translational research, I should say. This was exhibited in one of the, well, this version that's in the current slide is mobile app connected version, moving from the previous prototype, which had sort of threads, conductive threads attached to the clothing. This was the next version where it's much more functional and features in it. So this is when it was featured in one of the public exhibitions. It's called Energize Fashion Runway on Wearables and E-Textiles in National Science Week in 2015. And then I sought funding, and then we went into the next stage of laboratory validation, where I collaborated with colleagues at our MIT in Bandura campus. We have very cutting-edge thermal mannequins and thermal chambers where we can simulate the construction work conditions and their metabolic rates and various activity levels and so on. And this was also published as well. And from that, it was featured in various news like Channel 7, SBS, and so many prior to COVID, obviously. And the focus of this presentation today is part of the work we did in construction sites in residential sector. And these are the sites in our Melbourne sites. And some of them are multi-unit, and you can refer to further details. So just to highlight what we did and what we collected in this site tests. So if I start from this area, as you all know, we have a Bureau of Meteorology, we call BOM data coming from weather stations, nearest weather station in the country. So in addition to that, on site, we had two mobile weather stations, and then workers were wearing the vest, and we have microsensors placed. They are wireless sensor network placed in the construction site, and the vest data was coming to the mobile app, and they are all cloud connected and in real time. In addition to this mobile app, the management of the organization can visualize what's happening on site in various zones, and the alerts and conditions of the sites in management system in illustrated here. So in addition to this data that we collected, we also got perceptual data from the workers about heat stress related demographic hydration levels and also their clothing, activity phases, and so on. Also, the researchers collected observational data, heat stress and activity related. In addition to that, we also collected some system evaluation data from the workers as well as in-depth interviews with the management people. What we are presenting today is the data from the sensors here. We didn't incorporate the SmartWest data yet. Finally, what did we find out? So there were some eye-opening findings in this study. Firstly, we found out that the portable weather station data told us that site weather conditions recorded temperatures were higher than Bureau of Meteorology weather station, BOM weather station data by 4.4 to 8.8 degrees. Secondly, microclimatic conditions that we measured in various activity places on site. As you can see this in metric charts, these site conditions were way outside the thermal comfort envelopes on site. And then also the general thermal site conditions, we looked at the variability of measured temperature and humidity, and elevated temperature conditions were observed, and they were consistent with the site activities actually happened on site. For example, direct exposure to sun or concreting activities or certain activities that sort of elevated the temperature conditions. So these, you can refer to the paper for further details on this. So finally, to conclude, as I said, site conditions demonstrated elevated thermal environments and which alarming risk to workers' health and safety. And the policies in place, even for unionized sector here, is of limited effectiveness. And we are working on looking at the other data. For example, the data we collected from SmartWest temperatures and also other observational data and heat-related perception data analysis is still ongoing. So I'll probably stop from there. Future work, I'll probably skip. If you have any questions, happy to answer.
We do have a couple of minutes for questions online or in the room.
No question. Yeah.
Just a great initiative and yeah, great presentation. And I really love the fact that it's also focusing on it can help with issues that are not you call hard stuff like mental health improvement, especially after we heard yesterday that we are now, well, in Australia, suicide is so high. So I think this kind of research is really important. Well done.
Thank you. So I think I didn't mention, I didn't have time. I thought I'd save some time for you to enjoy the lunch, but it's part of the next phase that we are going to look at the productivity in particular. So incorporating other sensors, and it's ongoing at the moment. Thank you so much.
Okay, so we will conclude this session. Just let me remind everybody there is a follow-up session on accelerating innovation in construction at 13:30 in the same room. We invite you back. Have a good lunch.
Yeah, thank you all for great discussions and presentations. And as Brian said, we hope we will see you in the next session of accelerating innovation in construction management, in construction industry later. Thank you very much.